Hello everybody, welcome to Kamsa Joint Mock 2026. Don't forget to share and like. Now item 1, I'm going to break it for you down, but before breaking it down, allow me read it for you. Item 1 says, in your school, students have been complaining of high temperatures in classrooms and through their student representatives. They demanded that water cooling cans be installed in classrooms so that they can access cool water to quench thirst caused by the high temperatures. In response, the school administration has constructed a company to make cooling cans for the school. The can should be cylindrical with a height h is equals to 3.5 positive negative 0.2 meters and radius r is equals to 1.4 positive negative 0.1 meters. The school administration needs to know the least and greatest volume in cubic meters of water the cans can hold. In testing the cooling properties of the cans, the temperatures in degrees Celsius of cooling cans measured every 10 minutes were recorded as 82, 70, 56, and 42, with the can's initial temperatures being 93 degrees Celsius. The second welfare teacher argues that with the can's cooling properties, the water in the can will eventually freeze after some time, but can't tell how long it will take. He also wants to know the time it takes for the water to cool to a mean temperature of 50 degrees Celsius. The task is so precise and the question has been so precise. The task says that as the company representative at the school, provide the school administration and the welfare teacher with the answer they need. Thank you. So when you look at that item, the first problem that needs to be resolved is the school wants to know the minimum and the maximum water that can be held or that can be held. That one comes from the topic of mensuration. Specifically, we're looking at the volume of the cylinder, plus where you're going to get the max and the minimum error. The interpretation is there. You have to know the formula. Volume is equals to pi r squared h. Methodolize it, compute it, justify it to get your mean and max that the water can hold. The second problem that we can get from that item is that the teacher says water will eventually freeze after some time. That one you're going to get it from interpolation, Newton's law of cooling. If you look at Newton's law of cooling, exponential decay. Interpretation, the temperature data is decreasing, but rate slows. Methodolize it, compute it, and then you justify it to ease the understanding from that question. Now, the third problem there we're looking at is teacher wants time when t is equals to 50 degrees Celsius. Hope you have seen that. So that one is inverse interpolation. You can even use linear. Lagrange interpretation there is find the time when the t is 50 degrees Celsius between t. So that is it. You find it from inverse interpretation. Linear, Lagrange. So you can easily compute that. Don't forget to share. Thank you.